Question 11. The percentage distribution is shown in the diagram, in the graph. Find values such as x1, x2, x3, and x4. Now this diagram looks pretty complicated. Let's look at this diagram in some details. This entire distribution, and this corner is 10%, and from this x1 to x2 is 18%, from x2 to x3 is 31%, from x4 to the right, this whole corner is 29%. So what we need to find out is the value of x1, x2, x3, and x4. Okay. Now there are something peculiar about this diagram. We know so far a lot of calculations that are involved. We need to know where is the mean. But for this diagram, we don't have the line that shows the mean. What we can do? You can add that line to show the position of the mean to make this very convenient. Actually, we need that line to show where is the mean. So if there's a diagram that doesn't have the things that you need there, use the logic to put where it should be. So we add this mean here. So this is where the mean should be. Okay. Now, let's start calculation by looking at x1. We'll look at x1 first. Okay. Obviously, for the kind of calculations we are doing now, we know all this percentage distribution. We know the percentages. We need to find out the value of the original variable x. Obviously, for each of those, value x1, x2, x3, x4, we need to know the corresponding z-score, how far they are from the mean. Okay, so we need to find out, for example, x1. From x1 to the mean here, how many standard deviation it is? What is the z-score here? That is something we need to find out. Okay, and we know that we need to use a normal table to help us to do that. Now, to look up a normal table, we need to know the percentages. For x1, we know the percentage for sure the 10%. Okay, can we go to normal table, use the 10% to find the corresponding z-score? Can we do that? The answer is no. As we said from the previous question, the normal table that we are using now is made in such a way that does not show the size of the corner. So again, see, the normal table we are using now does not show the size of the corner. It shows this slice from the middle extend to a certain z-score here. It does not show the size of the corner. Therefore, it come back to the question, 10% is the corner. You cannot use the 10% to look up a normal table to find out the z-score. What you need to find out is from x1 to the mean, what is the percentage? What is the percentage? And use that percentage to find out the z-score in the normal table. Okay. So if the corner is 10%, what is the percentage from x1 to the mean? Obviously, you already find the answer. From x1 to the mean is 40%. It's 40%. With this 40%, well, you already know the answer. From the 40%, let's go to normal table. Let's pretend that we do not know the result yet. Okay, let's use 40% going to normal table to find a z-score. Okay, 40%. So in the table, we need to find a percentage number that closest to 40%. Now we have two numbers here. One is 39.97, the other is 40.15. Let's use this. Okay, let's use this. If we use this, let's see what should be the corresponding z-score. 39.97. 39.97. Let's go look to the let's make the table smaller a little bit. Okay. 39.97. You look to the left 1.2 and hit 1.28. So 39.97 correspond to a z-score 1.28. 1.28. So that's why we have this. We find the z-score 1.28. What do we do now? We bring this number into the formula. X1 is, you write down the formula. Remember, every time you do the calculation, you need to write down the formula first. Mean plus z-score times standard deviation. When you actually bring in the z-score 1.28 into the calculation, again, there's a negative sign here. Why negative sign here? Because x1 is to the left of the mean. You need to bring in this negative sign. Okay, negative 1.28 times 6.3. Complete the calculation, you obtain the value 69.94. So the value of x1 is 69.94. Okay. Use pretty much the same procedure. We're going to calculate x2. Okay, let me go back to one step. x2. Use pretty much similar procedure. We're going to calculate the value of x2. x2, look at that. x2. To find the z-score that corresponds to x2, again, we need to find out the percentage from x2 to the mean. The diagram does not directly give us that percentage. The 31% is from x2 to x3. We cannot directly use 31%. So how do we find out the percentage from x2 to the mean? Let's look to this corner. In this corner, we know from x1 to x2 it's 18%. Okay, then from x1 to the left is 10%. This big corner to the left of x2 is this corner plus this slice. Big corner. So is 10 plus 18. So big corner is 28%. So 10 plus 18 is 28%. So the big corner is 28%. Now you want to find out the percentage from x2 to the mean. What do? Subtract this corner, the big corner, 28% from 50%. Okay. You subtract 10%, 18% from 50%, you obtain 22%. And using 22%, so from x2 to the mean is 22%. Use this 22%, you go to normal table to find out the z-score. Again, we'll pretend that we don't know the answer yet. Let's go to a normal table. Okay, well, we know that we have 22%. Now, find a percentage number closest to 22%. You have a 21, 90, 22, 24. Let's use this one. Use this one. And turn out that the corresponding z-score is 0.58. 0.58. Okay. From normal table, z-score 0.58. Now we bring this z-score into the calculation. Now, before we bring it in to the formula, one thing you need to remember that this x2 is also located to the left of the mean. Therefore, the corresponding z-score should be negative. So that's you need to really remember this. Remember this. Okay, that's why we bring in all the values into the calculation, but this z-score is negative. You complete the calculation, you obtain a value 74.35. 74.35 is the value of x2. Okay? Now, x3. We can use a similar procedure to calculate the value of x3. But now x3 is located to the right of the mean. But we just have to follow almost exactly the same steps. We need to find out the z-score that corresponds to x3. For that reason, we need to find out the percentage between the mean and x3. Now, we know that this corner is 29%. If we know the size of this slice, and we can subtract this 29%, subtract this slice from 50%, and that would give us the percentage between x3 and the mean. Make sense? Okay. What is the size of this slice? It's not given to us, but you can calculate that. 29% here, 31% here, 18% here, 10% here, but the whole thing is 100%. So this slice can be easily calculated. Okay. 100% minus 29% minus 31% minus 18% minus 10%. So this slice is 12%. 12%. Okay. So 29%, 12%. You subtract 29%, subtract 12% from 50%. What you obtain is the size of this slice. 50% minus 12% minus 29%, 9%. From x3 to the mean is 9%. You take this 9% to the normal table. Let's find out what is the corresponding z-score. 9%. Okay. Find the value closest to 9%. So you have 9%. Here, you have this A71, 8.71% and 9.1%. So this value is very close to 9%. So the corresponding z-score is 0.23. So we use 0.23 as our z-score. Well, I said 0.24. Let me go back to the table. 0.2. Oh, here. Okay. Let me see. Why do I use? Is 9%. Okay. 0.2. Let's use 0.23. Looking at this table. Look at this. Obviously, 9.1 is obviously closer to 9% than 9.48. So let's use 0.23. Okay, 0.23. So Z score here is, let me go to make some change to the question. Okay. There should be 0.23. Okay, 0.23. Therefore, there should also be some change here. 0.23. Okay. So now 0.23 Z-score is positive. Why it is positive here? Because x3 now is above the mean. Is above the mean. So we bring 0.23 into the formula as a positive value. Now 0.23 times 6.3 plus 78, and this gave us a value of x 79.45. 79.45. So sorry, there's some further mistakes here. Okay. So the value of x3 here is 79.45. Okay, 79.45. Okay. So far we have calculated the value for x1, value for x2, and value for x3. There's some errors there which is corrected. Now, at home you can practice to calculate the value of x4. For x4, the procedure should be exactly the same as we demonstrated. You have this corner, 29%. Therefore, from x4 to the mean should be 50% minus 29%, 21%. You should be from x4 to the mean should be 21%. For 21%, let's go to normal table to find out what is the corresponding z-score. Find a value closest percentage closest to 21%, and could it be 88 or 21, 23. So let's use this. Use this value here. If you use this percentage, the z-score would be 0.55. 0.555. If you use this score, obviously z-score will be 0.56. So you can use either one. You can use either one. So you can decide to use this one, 0.55. And come back to the question. If you use 0.55, the value of x4 would be, you bring in all the numbers into the formula, 78 plus 0.55 times 6.3. Okay. 0.55 times 6.3 plus 78. The result should be 81.47. So the value of x4 should be 81.47. Okay. So at home you can practice to calculate the value for x4. Last question. As a SIOE student, commuting distance to school follow a normal distribution with mean 21.4 and standard deviation 3.5. Suppose that 15% students receive subsidies because of their long distance commuting. What is the threshold travel distance at which students are qualified for a travel subsidy? Now, we have this distribution, student commuting distance, okay. And we have this 15% in the corner. 15% in the corner. Students who travel beyond this distance, because they travel very far, they can receive travel subsidies. Okay, the question is, what is this distance? What is the minimum distance at which students start receiving subsidies. Okay, all the distance to the right of x, obviously is longer than this distance. But we are looking for what is this minimal distance at which students begin to receive uh, subsidies. Okay, this distribution we know. Again, we have this corner set 15%, and we cannot just take this 15%, look up a normal table to find the z-score that corresponds to 15%. We cannot do that. Why is that? I guess you already can answer the question, because the way that the normal table is made up, we are using that table, you cannot directly find out the z-score that corresponds to this corner by using the table that we are using now. If you are using a different table, that's a different matter. But now we have to find out what is this slice here, and that is subtract 15% from 50%, you have 37%, 35%. So that is 35%. Now we take 35%, go to the normal table, find a value closest to 35%. We have 3485 and 3508. You can use either one. So I think I may have used 3508. So if we use this number, and the z-score would be 1.04. Would be 1.04. Okay, let's see whether let me see which one do I use. Or I must use the other one. Okay, I must use 3485. I must use this percentage. Therefore, the corresponding z-score is 1.03. Okay, let's come back to the question. So the corresponding z-score is 1.03. And I will bring this z-score into the calculation. Same formula, mean, standard deviation, and z-score. Now the z-score is positive because this value occurs to the right of the mean. Complete the calculation, you obtain the value 25.01, and this is a 25.01, and this is what we needed. Okay, there's a similar way to check your answer. And this value is located to the right of the mean. It has to be larger than 21.4. Okay, so these are the questions where we use a normal table to help us to do the calculation. I hope this helps. I see you next time. Goodbye.